Hello, implemented memory offloading functionality in Sparrow. This means when we load model through MLX, in this case specifically, it works fine. It runs inference, it's producing response. But if you load the model from FastAPI environment, when you want to expose the inference functionality through API, model will stay loaded after the inference request completes. This means it would run in stateful mode. And if you don't have like too many requests happening, it doesn't make sense to keep entire model loaded in memory. It's better to release the model and make memory available for some other tasks. So to implement it in stateless way. And they found it works quite effective. And to release the memory after the inference, if we run sub-process functionality, this sub-process functionality is part of core Python, let's say, runtime. What it does, it allows to call a function in subprocess, and as soon as the function executes, then subprocess will close and it will automatically release all the memory that was assigned or attached to that subprocess. So there would be no need for you to worry how to unload the model manually and so on. So let's see this, for example. This is the remote desktop of my Mac Mini server, and you see currently there's around 20% of memory loaded, no GPU usage, because FastAPI application stays idle. Right, and now let's execute the request from FastAPI. This is the query, this is the options. We're using 72 billion Q12 visual LLM model with 4-bit quantization. Okay, and we pass the file for the inference. So we execute it now, and if we switch to the server, we see that request is executed. Memory models being loading models being loaded. It's finished loaded. It's around 81%, and we see that GPU started its work, loaded almost 100%. And here in log we see that the query is executing with Sparrow parse. We're preparing query and schema, executing query, and we output information about the file, and then text input. Okay, so the idea is that as soon as this request is done, we'll see the result, and memory should be reclaimed to previous like 20% or something. By default, if the process would not be used, then even after the inference request completes, memory would still be allocated at the same level like we see now. So the model I'm executing, it's Q12 vision model 72 billion parameters model. It takes time to execute, but actually it's executed just now, and we see that as soon as the response was printed, GPU was deallocated, and all the memory which was occupied is also deallocated, which is great. And now, if we can switch back over here, let's see, one moment. Let me bring this window over here. So we can see that the output was produced fine, and inference was completed. Now, if you look a bit into the actual implementation, so we'll see that on the main Sparrow LLM project, under Sparrow parse agent, we have execute query, and here we got some documentation which describes input parameters, and this is where LLM backend call happens to execute the query, and we're using Python process pool executor. We pass all the parameters that are required to be passed for the inference, and here we pass function name subprocess inference. So and then over here we'll get back the result, LLM output and number of pages. Those two variables will come from the Inference backend, where actual MLX is being integrated and is being executed. So in terms of MLX inference, there is no change because all the MLX specific code is inside MLX backend, and if you would run with Sparrow inference not on MLX but on NVIDIA, this code would stay the same, and the only difference is in configuration parameters we would need to pass flag to run inference not on MLX but on NVIDIA GPU, for example. And let's see how this subprocess inference is being defined. It's here in the top. This is the separate function. For subprocess to function properly, it needs to be outside of the class. And over here we import VLM extractor, which is a generic class which works with either MLX or NVIDIA. And we import inference factory here. We get configuration parameters here. We get using the configuration parameters we get correct factory, and this will be either MLX or NVIDIA or, for example, Hugging Face Cloud GPU backend which would execute the inference. And then we call generic run inference method. We pass all the information here, for example, tables only we pass as well, and yeah, we return back the output, and then the inference, once the inference is complete, output will come here and it will be returned back to the caller. And now let's quickly check the parse, Sparrow parse. And Sparrow parse, this is the place where specific LLM backends are being implemented. In this case, this is a generic VLLM extractor, which handles like such thing like table extraction, for example, if table only flag was sent to extract tables only, and does some other generic logic. And MLX specific logic is implemented under MLX inference. There's another one, Hugging Face inference, if you're running Hugging Face GPU. And if you'll open MLX inference, this is the inference function where all specific MLX logic is being implemented. Like in this case, if there are multiple files are being sent to process in batch, then each file will be processed and results will be aggregated and returned back to the caller. So that's probably what I want to describe. And my main point is that with subprocess is in Sparrow is very convenient now to handle API requests and offload the memory as soon as the API request completes and run all this VLLM interaction in stateless mode to make sure that several resources are being released when inference request completes. So thanks for watching and see you next time, probably in the next year. Bye.